Hi guys, in this video we're gonna go over entire chapter 4. Chapter 4 is working with the probability functions. In chapter 3 we talked about the basics of probabilities topics. We went over a couple terms, definitions, and then go over how to calculate some simple probability, something that you have experienced in like everyday life. What is the chance of getting a girl when you're giving a 3 birth, right? Now in chapter 4, we are going to go over some more mathematical probability function. Chapter 4, we are going to be particularly talking about the probability distribution that deals with the discrete random variable. Now we talked about the discrete data before in chapter 1. Remember discrete versus continuous? And I mentioned that discrete data are finite number, whole number. So your variable will deals with the whole number value. In chapter 5, 6, we are going to go over some continuous variable. In that case, we are going to deal with the decimal value as well. X could be not the whole number, but decimal number. Okay, so we'll mention about those in a bit. But let's begin with 4.1. The very first type of a probability function that we are going to go over in chapter 4 is probability distribution function. Now, what is a probability distribution function? It has a two characteristic. One, each probability is between 0 and 1 inclusive. And number two, sum of the probability is 1. So first one is called probability distribution function. And we have seen this concept in chapter 3. When we calculated the probability, I mentioned that you cannot go over 1 because you cannot have over 100% probability. So it makes sense that when you calculate each probability for the event, it has to be a number between 0 and 1. Now, if you're adding all the probabilities for that event, of course, it has to equal to 1 because that makes up the whole 100%. So that's the basic 2 probability. But I'm actually introducing it right now with the formal term. If two characteristics of those are met, we call it probability distribution function. Okay. Example, suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of time, 2 days, 15% of time, 1 day, 4% of the time, and no days, 1% of the time. Suppose 1 week is randomly selected. Let X be the number of days Nancy attends class per week. X takes on what values? B, suppose 1 week is randomly chosen. Construct the probability distribution table called a PDF table. All right, so let's first answer part A. X takes on what value? X is your discrete random variable. Now, I'm going to first identify what X is. Well, actually, the problem wrote what X represent. X is the number of days Nancy attends class per week. So it's a number of days. So it has to be a number, okay? Not a categorical data, right? It's going to be a numerical. Well, number of days Nancy attends. Well, here she has classes 3 days a week. So the possible days that she can attend is 0 time, 1 time, 2 times, up to 3. And that's it. You cannot attend 4 times of day because the class holds maximum of 3 days a week. So all the possible days that Nancy can attend class per week is either 0 time, 1 time a week, 2 times a week, and 3 times a week. And this is what I mentioned about whole number value. This X represent the whole number value. So this is a discrete random variable. Okay. Suppose 1 week is randomly chosen. Construct a probability distribution table called PDF table. PDF table is basically a T-chart that has an X and then its probability value. So here we have an X that represents the number of days and then associated probability value for that X. So there's only 0, 1, 2, 3 possible X value. And then so this is how you interpret it. X, P of X, which is a probability for the X. So if P of 0, right? What is the probability that Nancy attends 0 times a week? Well, let's take a look. She attends class 3 days a week, 80% of time. So there's that description. Let's highlight it. She attends class 3 days a week, 80% of time. 2 days a week, 15% of the time. 1 day, 4% of time. No day, 1% of the time. So that is all the probability given to you. So you do not have to calculate it for this one. So this is an easy example. All I have to do is, okay, so no days, we have 1%. You can write 1% or a decimal value, so that will be 0.01, right? Converting percent to decimal, we move 2 to the left, 2 decimal to the left. 1 time, 1 day, the probability value is 4%, which is equal to 0.04. 2 days, 15% of the time, so that's 0.15. And then number 3, so 3 days a week, the probability for that is 80%, so 0.80. So this is called a PDF table, okay? What is a PDF table? It has a X, the discrete random variable, and its probability value. Now, it didn't ask for this, but let's see if this example is a probability distribution function. We're going to go over different types of functions, so do not mix up the characteristic. We're going to go over probability distribution function, and later on, we're going to also go over the binomial distribution. So you do not want to mix up those two functions. Okay. Chapter 5, we are going to go over something else, normal distribution. So you're going to see all different types of distribution function. Normal distribution, uniform distribution. There are like 3 more to go. So I would keep all these characteristics pretty straightforward. So in order to confirm that this is really a probability distribution, all you have to do is you just go back to the characteristic and check off to see if both conditions are met. Number 1, each probability is between 0 and 1. Well, here 0.01 is between 0 and 1. 0.04 is a value between 0 and 1. 0.15 is a value between 0 and 1. And 0.80 is also a value between 0 and 1. So number 1 is met. So each probability associated X value is between 0 and 1. Done. Now number 2, the sum of probability is 1, so let's add them up to see if it equals 1. 0.01 plus 0.04 plus 0.15 plus 0.80 does equal to 1 whole, 100%. So at this point, we can conclude that this is an example of probability distribution function. Okay, so the first type of a function is pretty straightforward, not too bad. Now, with the probability distribution function, there are a couple other formulas to help us find out data. So mean, variance, standard deviation. Remember, these are all the terms associated with the data analysis in chapter 2. Same thing. We have all these probability value. I could ask, oh, on average, right? That's a mean. On average, what is the probability Nancy attends class per week, right? So that's what the mean is for. Variance and standard deviation. Remember, variance is a square of a standard deviation, and then standard deviation was a measurement in comparison. Excuse me, in comparison to the mean value. So I'm gonna give you an equation for all three, and then we are going to be using that to answer example 1 and 2 on this page. Mean, the symbol for the mean is mu. Now, go back to chapter 1 and 2. I talked about, or chapter 2 particularly, in part 2 lecture note video, I talked about the difference between X bar versus mu. Remember, X bar is a sample mean, and then mu was a population mean, and I mentioned that, in chapter 2, don't worry about the difference between X bar and the mean. We are going to always associate it with the sample. Now it's time to distinguish between X bar versus the mean. Mean is the population mean. That means the whole entire set. This is the whole entire set. It's not a sample. It's there's nowhere on this example that tells you the sample size of 100 or sample size of 5 weeks. Suppose 1 week is randomly selected. It just mentioned that there's a 1 random week that they picked, and these are the whole thing that is happening within that week. So appropriate mean will be a population. So in chapter 4, we are going to start using the population, not the sample. Okay, so that's why I use the mu instead of X bar. So the mu is defined as, remember, it's the average, so there should be kind of adding things up. Sum of X times its probability value. Variance, remember, is a square of a standard deviation. So let me first give you the standard deviation formula. Square root of sigma X minus the mean whole thing square times P of X. Okay. And for the variance, because if you square the square root, they cancels out, so it will be basically inside of the radical. So sum of X minus mu whole thing squared times P of X. Okay. Now, unfortunately, we do not have a calculator function to calculate these values, so you have to use the formula. Okay. So for this one in chapter 4, make sure you're okay with the formula. Okay. The blank, the expected value of a discrete random variable x denoted by letter E, and it is the mean value of the outcome. So you mean and expected value are the same thing. You could say mean or expected value. That's basically asking you to find the average. Let's take a look at the example 1. The table 5.1 describes the probability distribution for the number of girls in 2 births. Find the mean, variance, and standard deviation. If you're giving a 2 birth, the possibility of whole thing, again, the whole thing, we are talking about the population, is either 0 girl, 1 girl, or 2 girls. That's it. That's the whole set. Okay? So 0 times probability, the 0 times having a number of girls in the 2 births, their probability is 0.25 or 25%. 1 time will be 50%, and then having 2 girls in 2 births, the probability for that is a 0.25. So let's begin with the mean value. Mean value, the formula is summing up x times p of x. Now, I'm just gonna add more columns to help me do the calculation a little bit easier. I'll do x times p of x for each probability, and then basically adding up this row right there, or that column right there, so that will be the sum. So let's do that. X times p of x, so that's 0 times 0.25. That will be just a 0. 0 times anything is a 0. Next one, 1 times 0.50, that will be 0.50. And then 2 times 0.25, that's 0.50. What are we going to do with all three numbers? There's the sigma, summing up x times p of x. So I'm going to sum this column. 0 plus 0.5 or 0.50 plus 0.50 will be equal to 1 whole. And this is how you interpret it. So in average, if you're giving a 2 birth, having a girl will be 1 time. Okay. Variance, sigma square. That will be a sum of x minus mu whole thing square times p of x. So I'm going to be adding another column, calculate these individual pieces, and then sum that up. Okay. All right, so x minus mu. Mu was, remember, we got 1. So I have an x, okay, so this is a 0. So 0 minus 1 whole thing square, and its probability for the 0 will be 0.25. Using the calculator, I got 0.25. Moving on, x this time is a 1. The mean doesn't change. Mean was calculated as a 1. So keep that mu value. P of x, 0.50, it will be 0. 1 minus 1, 0 square, anything times 0 will be 0. 2 minus 1 whole thing square times 0.25, I get 0.25. Here, I'm going to be summing that up. So I have 0.25, add 0, add 0.25. The variance will be 0.5. And standard deviation will be basically a square root of 0.5. So it is about 0.7, just rounding. Okay? So that's how you calculate the probability. Okay, example 2 is a really good exercise because you have to come up with a table that looks like table 5.1, and then you have to identify all these x, the discrete random variable, and then calculate mean, standard deviation, and mean, variance, and standard deviation. So it's kind of like you have to start the whole problem on your own. Create a table and then calculate the mean, variance, standard deviation. So let's go over example 2. And your homework will be much like example 2 as well as your exams. Okay. Suppose you play a game of chance in which 5 numbers are chosen from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A computer randomly selects 5 numbers from 0 to 9 with replacement. So we have with replacement. In chapter 3, we talked about that with replacement will be independent event. You pay $2 to play and could profit 100,000 if you match all 5 numbers in order. You get $2 back plus $100,000. Remember your $2 original bet and then how much you earn. So you are getting that $2 plus that 100,000. Over the long term, what is your expected profit of playing game? The main question is, what is your expected profit, expected value? So I have to find the mean value. Okay, now in order to find the mean value, we have to know the x value and p of x. So first, my question is, you could jump right onto a question and then start using the numbers, But let's begin with what x mean in this example. What is x? Remember, x represents discrete random variable. In example, on the very first page, they define the x for you. It's a whole number value. Here, they did not define the x for you, so you have to write down what x mean. Now, I'm gonna use like a sentence, like a word to explain what x mean, and then associate the x value. So let's do that. What does x mean in this example? It's a little bit confusing. Common way to approach is these 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the numbers that you can choose from. However, the question, this is why you have to read the final question. What is your expected profit? I'm not interested about the numbers. I'm interested about the profit. So X has to deal with some kind of a profit. Okay? Not a number from the game. Okay? So it has to deal with some kind of money involved when I write down the X. So let me give you a minute to think about this and see if you can identify the X. Okay. So X is defined as amount of profit or the money you receive playing game. Okay? Because the problem asks you to find the expected profit, so your X has to deal with the profit or the money. Okay, so let's draw the chart then. Create the PDF table. X and P of X, right? So X is amount of profit or money you receive during the game. Okay, well, I'm gonna add another column to help you visualize. So what are my possible X value? Remember, X is your money, so it has a number. But what are the cases? So how many X value do I have? In this case, we only have 4 situations. In this case, there's only 3 events, either 0 or 1 or 2. So when are the times that you could make, when are the times that you could get profit when you're playing the game? Well, there's 2 situations. You could lose the game, or you could win the game. Now, if you're losing, of course, we don't consider that as a profit because you're losing money. But you cannot eliminate this event because it's possible that you could lose money. Other situation is win, then you gain profit, right? Now, let's talk about the net profit. So I'm not counting that $2 your original, but it's just the pure profit. Now, if you lose the game, the X will be what's your profit? You lose $2. So there's $2, but I'm gonna use a negative value to indicate that it's losing. Winning, the X value is $10,000. Correct? Now, for probability, what is the probability that you lose $2? Well, in this game, how do you win the game? A computer randomly selects 5 numbers from the 0 to 9 with replacement. You pay $2. If you match all 5 numbers in order, you win. So there's just 5 places, 1, 2, 3, 4, 5, right? So for example, you match all 5 numbers in order. So let's say you have, so example for winning will be like 1, 2, 3, 4, 5. That's the number, all 5 number match in order. 1, 2, 3, 4, 5. Or if you pick the first number as 2, then it will be 2, the next number will be 4, 2, 3, 4, 5, 6. Okay. Now, then let's calculate the probability for winning. Well, what is the chance that you select 1 from the pool? Well, there's 1 out of 10 chance. Then the next number, what is the probability that you're gonna select 2? Well, again, because it's with replacement, I'm still going to have 10 numbers available, but having 2 will be 1. What about 3? 1 out of 10 again. 1 out of 10, 1 out of 10. So this will be 1 over 1, 2, 3, 4, 5, 10,000 or equal to 0.00001 chance. So that will be your winning probability, 0.0001. Then what will be losing? Well, if this is winning from the 100%, so 1 take away 0.00001 will give you 0.99999, right? Because remember, these two has to add up to 1. So if you have 0.00001, 1 subtracted, that value will be 0.99999, okay? So let me erase this scratch work. So there you go. Now I'm gonna pause for a minute and then tell you recap quickly what we just did. So in this example, there was no x defined for you. So it was kind of challenging to think of that x represent the amount of profit money you receive. Once you identify x, you have to identify the numerical value associated with x. In this case, the profit is either, gaining the 10,000 or you could lose. So you have a -2. After that, we calculate the probability. All these numbers are not straightly given to you in the problem. It was nice for the very first one. They give you the percentage value. But in this example, you have to calculate it on your own. Many times you have to do that. So coming up with the x correctly and then setting up the table is important in order to proceed the problem. The final question was asked to calculate the expected value. So let's calculate the mu value. Mu is defined as x times p of x. So I'm going to create another column, x times p of x. Let's multiply those two numbers, -2 times 0.99999. I'm getting -1.99998. You have 100,000 times 0.00001. The final answer I'm getting is 1, so I'm going to add those two columns for the mean. -1.99998 plus 1 give you -0.99998. So this is, close to, right? Because we are dealing about, again, the money, so 0.99 is rounding to the whole number -1. So that means on average, well, first of all, you have a negative, so you're losing money. So on average, you're expected to lose approximately $1 each game you play. So let me write a sentence. You could, on average, expect to lose approximately $1 for each game you play. Okay, so every time you play, you're gonna lose about $1. Moving to the next part. This is another type of discrete random variable. We call this binomial distribution. So Today, we learn about two different functions, probability distribution and binomial probability distribution. Now, by probability distribution, we had a two characteristic. Binomial probability distribution, we have four characteristics. So let's take a look at the four characteristics. And this is a little bit more complicated than the first function, the probability distribution. Okay, number one, the procedure has a fixed number of trials. So there's a set amount of a number for that event. Number two, the trial must be independent, sample with replacement, without replacement, with 5%. Don't worry about this. You can actually eliminate that. Remember, another word for the independent is a sample with replacement. Number three, trial must have all outcome classified into two categories, success and failure. So there's only two categories available. Number four, the probability of success remains in all trials. So that means the succeeding rate will be the same for all trial. And that's because it's independent. The number do not reduce down, so it will be all same. Okay, here's the notation for the binomial distribution function. This is just a notation because later on when I introduce three more other probability function, you're gonna have hard time which one is which. So we use the notation to indicate that x, the discrete random variable, represent the binomial for letter B. Okay, and then n comma p tells you some information about this binomial function. N represent fixed number of trial, p represent the number of success. Okay, because we have a success, the other one is a failure, so we use letter Q. And then x represent the specific number of success in trials. P, this is same thing, P and Q right there. And then we use the notation P of x to represent the probability of getting that particular x value among the n trials. So just like the probability distribution, we have mean, variance, and standard deviation equation. Now, this over here, mean, mu is equal to n times p. Very simple. Fixed number of trial times probability. Variance will be a n times p times q. And then standard deviation is a square root of sigma squared, so it will be a square root of npq. Mean, variance, standard deviation is easy, but this one over here, calculating the probability value itself is a little bit challenging. Here, with the last example, these two numbers that we calculated was not too bad. Remember, we just identified, 1 out of 10, 1 out of 10, 1 out of 10, 1 out of 10, and then we found that it was a 0.00001 and then subtracted. That was pretty simple because the probability function itself is simple. However, binomial distribution is a little bit hard. That P of x, calculating each probability like these one, it's not as simple as counting the events and then calculate it. It involves some combination rules and then succeeding rate and then failure rate and then having that power. Okay, so you could use the formula, but fortunately we do have a calculator function for this. So I'll show you a better approach to calculate this probability value using the formula. Okay. On TI 8384, to calculate the P of x for the binomial, I'll list out the steps for you so you have it here, and then I'll pull out the calculator and then show you how to calculate it. You're gonna press the second key, vars, and then to 0 binom F. Okay, and you're gonna put it in order of N, P, X. All these, it's okay if you do not follow it at this point. I will show you how to do that on the calculator. Calculator. Okay, so let's actually use this next example and then learn how to calculate the binomial probability formula. Example, in 2013 art supplies catalog, there are 560 pages. 8 of the pages feature signature artists. Suppose we randomly select 100 pages. Let X be the number of pages that feature signature artists. Okay, so fortunately, this time they give you what the X value is. This is X represent the number of pages that feature signature artists. So let's jump right onto identifying some X values. Okay, so there are a couple numbers here, these two important numbers. There are 560 pages. Suppose we randomly sample 100 pages. Okay, so 100 pages. That's your what? N, fixed number of trials, sample size. On the side, I'm just gonna write down N, 100. Okay. All right. So if you are randomly opening that catalog 100 times, what are my number of pages? So what are my X value? The number of pages that feature signature artists. 8 of the pages feature signature artists. So there's only 8 maximum. So you open up 100 pages, there is a possibility that none of them shows that feature signature artists. You open up 100 samples, 100 pages, and only one time that you could see the feature signature artist. So how many? All the way up to 8. What is the probability distribution? Now this question is asking what type of a probability distribution function it is, and then write down the notation. Right now you just have two things to consider. It's either gonna be a probability distribution or binomial distribution. But how do you know which one is which? You look at either 2 characteristic or that 4 characteristic. This is pretty easy one. It has the concept of that fixed number of trial, that sample size. Okay, so I have a feeling that it's gonna be a binomial distribution. But remember, it has to meet all 4 requirements. So let's go through the 4 requirements to confirm that it is binomial distribution. Okay, has a fixed number of trial, 100. Trial must be independent, sample with replacement. What does that mean? Okay, so you open up the page and then close it and you reopen. That page will not disappear, right? It will still be the 560 pages unless you're ripping a page, but it didn't say there. So it's an independent event. Number 3, do I have 2 outcomes? Yes, have feature signature artist or pages that do not feature signature artists. So there's 2 conditions. Number 4, probability of success remain all same trial. Do I have each time that I open up the 100 pages, is my chances of having that signature artist same? Yes. What is that number? Well, that will be, each time I open up, I'm going to have what? 8 over 560 chance of getting that pages for the signature that features signature artists. Okay, so it is a binomial, so I write down, okay, this is a binomial distribution with n comma p, so fixed number of trial 100, and then probability of having the feature signature artist for each time will be 8 out of 560. Okay, now if I give you this whole notation, it's already telling you a lot of information. Okay, it's a binomial distribution. First number that you see 100 that represent always the n. Okay, so it's a sample size of 100, and then the success rate will be 8 out of 560. Okay. Find the probability that features two pages. Find the probability that 2 pages feature signature artist. Okay, so that means I want x to be equal to 2. Okay, so that will be probability that x equal 2, right? Or you could have write it this way too, p of x. Oops, p of x equal 2, right? Okay. You could use this messy formula, but as I mentioned, I'm going to show you how to use a calculator to get the number. Pretty simple. So we are going to use binom PDF. You have to put these 3 numbers in the order. That's what the calculator needs minimum requirement. They have to know the n, p, x. You have it n, 100, p, 8 out of 560, and then x number 2. Now if I say find the probability that 3 pages feature signature artist, then x will be 3. So x can change. Remember, x can be from 0 to 8. All right, so on the calculator, okay, here's your home screen. Remember I told you second key vars to get to the binom PDF. Okay, so here's my second key bars. Bars is next to the clear button. We are pressing the second key bars to get to the distribution. Okay, now over here it lists all the distribution. Now for my particular calculator, it is actually letter A. You see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then you have the binom PDF as A. Some calculator has it under 0, so it depends on what type of calculator, so you can check, but you press that A, binom PDF, okay? And then you're gonna press 100 and px. Remember 100, comma, and you have to use a comma button to separate 3 numbers. And then you have 8 over 560. Okay, and then the last number is 2. Close the parentheses, enter. You get 0.2466. Okay, about 24.6%. That's it. Pretty simple. So I'm gonna write down this one here. Binom PDF 100, 8 out of 560. Those are the number that we put. We get 0.2466, about 24.6%. Okay. So if you open up 100 pages, having 2 pages that feature signature artists is about 24.6%. Next one. Find the probability that at most 6 pages feature signature artists. Now, there are many words that describe. Part C, we have 2 pages. Part D, at most 6 pages. Part E, more than 3 pages. These are all mean different. Okay? 2 pages is exactly 2. When we say something is at most, I'm not talking about 6. I could have 0 pages that feature signature artists. 1, 2, 3, 4, 5, up to 6, right? So when we say at most 6 pages, I'm really talking about P of x less than or equal to 6, right? At most means all the way up to 6, okay, not including 6. Okay, so what does that mean? Having 0 is okay. Having 1 page is okay. Having 2 pages okay. Having 3 pages okay. Having 4 pages okay. Having 5 pages okay. Also having 6 all the way up to 6 is okay. Now, there's all the way up to 8. If I'm including 0 all the way up to 6, I'm expecting a probability a lot bigger than part C because I'm adding the probabilities. However, you know that it's not going to go over 1, so make sure you're checking that the number makes sense. Okay, so that means we have to use binom PDF and then calculate these 7 probability and sum that up. Okay, so let's do that. Let me pull out a page, a blank page, because the lecture note has a small space. So I'm gonna write down over here better one more time. Remember part D? Part D was probability of x less than or equal to 6. This was P of 0, P of 1, P of 2, P of 3, P of 4, P of 5, and P of 6. I'm not gonna write down the whole thing, but just for the first one, I have to do binom PDF 6 times. So it will be binom PDF for the first one, NPX. N will be 100. P will be 8 out of 560. And then X will be 0. And then I need to sum that up with, right? So this one over here is this part over here. And then I have to add this one and then all the way up to 6. So the second one will look like binom PDF 100, 8 over 560, and then next one 1, right? So that will be this one. And then you have to do that all the way up to this last one being binom PDF 100, 8 over 560, all the way up to 6. Okay. So let's do that. And you can put this one all in once. Okay. So binom PDF 100, comma. So on the app, I just press the binom PDF. This one, if you have your physical calculator, you just have to go second bars and then, select the binom PDF. But I have it saved up there. So it was 100. Right, remember, I'm typing up this part over here. 100, comma, 8 over 560, comma, 0, plus binom PDF 100, comma, 8 over 560, comma, 1, plus binom 100, comma, 8 over 560, comma, 2, plus binom, we have 2, so we have more to go, 100, comma, 8 over 560, comma, 3, plus binom PDF 100, comma, 8 out of 560, comma, 4, plus binom PDF 100, comma, 8 out of 560, comma, 5, plus binom PDF 100, comma, 8 over 560, comma, 6. There you go. Close it. Remember, expecting a number a lot bigger than the previous answer, 0.2466, but less than 1. We have 0.9994 rounding to the 4 decimal place, and that seems a reasonable answer. So I'm gonna write down over here, the answer that we got was a 0.9994. Okay. Now, that was a lot of, that wasn't too bad because each one, the calculator calculated for you, but it was still a lot of work because the number, we had to add it from 0 to 6. But what if there was 1,000 sample and then X value was all the way up to let's say, 50, then you're not gonna do 0 plus 1 plus all the way up to 50. That's still a lot of work. So there's a new function called binom CDF. So here, I'm gonna do the same thing. Here I use the binom PDF function. I'm gonna use the same example, still dealing with P of, sorry, my screen is keep going back and forth. Binom CDF, P of X less than or equal to 6. We should get the same answer because we are dealing with the same example, still less than or equal to 6. But CDF is a lot better option than PDF. CDF represent binomial cumulative density function. Remember we talked about the cumulative frequency in chapter 2? Same thing. Cumulative means summing up all the way up to a certain point. So if you have a less than or equal to, it's a lot better to use a CDF, not PDF. Why? Because PDF, you have to use individual value and sum it up. CDF means you're going to include all numbers up to 6. So it's very similar. It will be binom CDF, and then it's going to be NPX. So you put still 100. P will be, doesn't change, 8 out of 560. And the number that you want to include is up to 6. So you're going to put 6 there. I'm going to use CDF this time, and let's see if we get the same answer, 0.9994. So calculator. Okay, so we have second bars, and you see the right below, you have a CDF. That's the binom CDF. 100, comma, 8 out of 560, comma 6, and you should get the same answer. 0.99389562521. So I did, in fact, got 0.9994. So it's a lot better, right? So you could use PDF if you like, but it's gonna take too long sometime. So I'm also going to show you that you can use binom CDF too. Binom CDF, and still it will be NPX. So know the difference between the PDF and CDF. Okay. 0.9994. Now, be careful also. The problem may not ask you to have less than or equal to 6. Let's say find the probability less than 6 pages. So this is a separate example. What if I just say less than 6, right? So that will be this time P of less than 6. I do not want to include 6. So you could use PDF, also CDF, but this time your binom CDF, the last number will be slightly different. This will be binom CDF 100 times 8 out of 560, and the last number should not be 6 because you're not included 6, but it should be 5. Why? This means P of 0, P of 1, P of 2, P of 3, P of 4, P of 5, but not 6. So that's confusing to a lot of students because we have a tendency that, oh, less than 6, there's my number 6, and you put it right there. But remember, this does not include 6, so the last number should be 5. So there's a bunch of practice on the homework problem that does it. So make sure you are okay with that. Same thing, when I say more than 6 versus more than 6 means 6 is not included, right? But I said 6 or more, then 6 is included. So in that, you have to modify the number, okay? Oops. So let's look at letter E, and that's that example here when what I talked about the more than part. Find the probability that more than 3 pages feature signature artist. Okay, so find the probability that more than 3. So I'm gonna first write it down this way. More than 3. Okay, so more than 3 means, okay, I'm gonna use also a scratch paper to explain this because we need a lot more space. Letter E, we have probability that x is greater than 3. What does that mean? Let's write down what that means before we use a calculator, okay? When I say greater than 3, in this example, I'm talking about 3 or more. So I want to make sure that I'm having that 3 plus 4 plus 5 plus 6 plus 7 and up to 8. Now, if you interpret it this way, so I'm going to show you multiple ways, okay? I'm going to show you both PDF and then CDF function. You choose which one you understand better, okay? But PDF, you're going to have hard time doing this when the number gets big. So that means if I'm doing this way, I will be using binom PDF how many times? 1, 2, 3, 4, 5, 6 times. Binom, oops. Okay, so binom PDF. I'll just write down the first one and then you can follow the pattern. 100 times 8 out of 560, comma 3, and so on. Okay. Now we're gonna get some answer there, right? So let's try calculator and see what answer we get. I'll clear it so that it doesn't get confused with the last one. Binom PDF 3, 4, 5, 6, 7, 8, right? Oh, I think I messed it up. I should not include 3. Sorry guys, because I am talking about more than 3, so that means I do not want to include 3. That means 4, 5, 6, 7, 8. Okay, my apology. Just cut that right now. So I should not have this one, but starting with 4. So this also should be 4. Okay, so 4, 5, 6, 7, 8, right? When we say greater than 3, that means 4, 5, 6, 7, 8. Binom PDF. N will be 100, comma 8 out of 560, comma 4. Adding that up with PDF, 100, comma 8 out of 560, comma 5. Binom PDF, 100, comma 8 out of 560, comma 456. Binom PDF, 100, comma 8 out of 560, comma 7. And then last one, binom PDF 100, comma 8 out of 560, comma 8. Okay. 0.0557, rounding to the 4 decimal place. Okay. 0.0557, rounding for the 4 decimal place. Now, let's use CDF. Now, remember, you have two options, PDF or CDF. But last example, I said CDF means cumulative, all the way up to certain point. Now, this example, you cannot use CDF right away because it's not from the beginning all the way up to a certain point, right? Beginning was a 0. Now I'm talking about certain point and on, 4 and on. So I cannot use CDF because it's not from the beginning all the way up to a certain point, but it was a certain point to the end. So how can I still use this CDF so that I don't have to sum up all these 5 numbers? You can still use CDF. Here's how you interpret it. Well, P of x greater than 3 is equivalent to, well, I am talking about 4, 5, 6, 7, 8. How do you get this? Well, I could interpret it this way. Here's my whole thing, but I can subtract this part, then I'm gonna get this 4 and 8. One more time. I have this whole thing to consider, whole event. I'm going to be subtracting this beginning part, then I get the remaining 4 to 8. And this is what it means. I consider one whole thing and subtract the beginning part. Isn't that what that means? One takeaway, right? This is same thing as one takeaway. Well, that's a P of 0, P of 1, P of 2, all the way up to 3. Then you basically get this part over here. Make sense? Okay, so that's another way to interpret it. So, okay, that means this part I can use CDF because that's less than concept. So you could write this way, one takeaway. Don't forget the one subtracting. That's the important part. We have this whole thing, but subtracting only this part to get the remaining piece. Binom CDF N 100, 8 out of 560, comma, this is all the way up to 3, so do not put 4, so you put 3 this time. I'm gonna put that and see if we get 0.0057. 1, take away, binom CDF this time, 100, comma, 8 out of 560, comma, 3 should give you the same answer. There you go, 0.0556807, right? Yep. So writing down 0.0557. Be careful if this is a separate example. I know this is I don't want to confuse, but there's all this different situation to consider when you're doing homework. If we are talking about P of x greater than or equal to, in that case it will be 1 minus P x is less than equal to 2, right? You are subtracting all the way up to 2. So in this case, you will have P binom CDF, and the last number will be 100, 8 out of 560, comma 2. So even though you see the 3 here and then you see the 3 here, these two means different. So make sure you're okay with this, because it's very tempting to see, oh, I see the 3, so I'm gonna put 3. I see the 3, I'm gonna put 3, but 3 is not correct. It will be 2. Okay. So let's add that over here. I use 1 minus p x less than or equal to 3. And I use 1 binom CDF 100, 8 out of 560, close, comma 3, got 0.0557. So very, very, be careful with C, D, and E using PDF and CDF, and especially CDF, the last number, 6 versus 3, including 3, not including 3, the number change. Last one, calculate mean and standard deviation. Remember, we use part B to identify that this is a binom. So use the binom mean and standard deviation formula, which is right over here. This one over here. Now, some people mix up the formula. Oh, they see the word mean and standard deviation, so they just randomly open up the page. Oh, I see the mean and standard deviation, and they use this formula. This is mean and standard deviation formula, but remember, this is for the probability distribution function. This is for the binomial, so you have to use a binomial distribution mean and the standard deviation formula, okay? I'm gonna show you the mean and variance and standard deviation formula for uniform and normal distribution. So you're gonna have a lot of formula at the end of chapter 5. So keep those formulas straightforward. Do not mix up those, because you don't want to use the wrong formula for the wrong distribution. But this one, the mean, I will use, it's very simple, a lot simpler than calculating the probability value. N times P, N was 100, P was 8 times 560, so 100 times 8 out of 560. On average, you're going to get 1.4286. This is a pages. You cannot really have a 1.5. So to interpret it in a reality, I'm just gonna say on average, you're gonna get 1 page feature signature artist page. Artist page when you open up 100 pages. But on WebAssign, they might ask you to round it to the certain decimal place, so follow that rule, follow that direction. Standard deviation is right there, NPQ, the square root of NPQ, so square root of 100 times 8 out of 560. Now here is Q that we haven't calculated, but what does Q represent? Probability of failure. There's only 2 categories. If you have 8 out of 560 chance of opening up having the feature signature artist, what is not having a feature signature artist? Q will be, right, the opposite. That makes the other whole. So Q will be 552 out of 560. Where's the 550 coming from? 560 take away 8 give you the other pages that do not have a signature artist page. So 552 out of 560. Put this all on the calculator. I'm getting 1.1867. Okay, so that's pretty much all the material for chapter 4. This is the last page. We talked about a lot with this function here, binomial distribution. Make sure you practice this example, that C, D, E, especially knowing the difference between PDF and CDF, and then knowing the less than, greater than, less than or equal to, greater than or equal to. Okay, thank you for watching.